Hello everyone, my name is Tariq and I'm a cloud DevOps engineer. This will be my first video on my channel. I decided to name my channel Think Out Cloud. I'll be making tech related videos on this channel with a focus on cloud technologies. For my first series on this channel, I'm gonna start with solving scenarios from satservice.com and taking you through my thought process as I solve these scenarios and how I figured out everything and solved everything. I think this would be pretty helpful to everyone that's trying to get into cloud DevOps and even people in cloud and DevOps right now. So let's start. What is satservice.com? SatService is a website that provides you with interactive servers that are not functioning as expected, and you have the task to fix these issues through SSH administrator access. Each one of these scenarios is ranked from easy to hard, and each scenario falls into one of three types, which are fix, do, or hack. Fix is where you react to an issue in the server and try to fix it. Do is where you proactively try to accomplish a task, while hack is where you try to perform a task that is similar to what a hacker would do when they're trying to attack a system. Everything is going to be more clear when I start working on one of these scenarios in a bit. I'll be starting with the scenario named St. John. What is writing to this log file, which is of rank easy and type fix. So let's go ahead and read its description. A developer created a testing program that is continuously writing to a log file, bad.log, in the directory var.log. And this file is filling up the disk. You can check the contents of the file using the following tail command. And the program is no longer needed, so we need to find it and terminate it. And this part explains the test condition used to determine whether you completed the task successfully or not. So it checks if the log file size doesn't change within a time interval bigger than the rate of change of the log file, which basically means the file size isn't increasing, which in turn means that the process has stopped writing to this file. This line explains the Check My Solution button, which you're supposed to click when you're done with your work. Also, we have 10 minutes to solve this scenario. So before we start working on the server, we should plan out how we want to tackle this problem. These are the steps I'm going to take to figure out this problem. Step 1. I'm going to examine the bad.log file using the tail command. Step 2. I'm going to find the process that's writing to the bad.log file. Step 3 is that we're going to kill the process that's writing to the bad.log file. And the final step is to use the tail command to examine the bad.log file again to make sure that the process is no longer writing to the file and that we've accomplished our task. So let's start. We're going to click this run button. The server takes about 50 seconds to set up, so I'll skip to when it's ready. Now that the server is ready, we click on the hyperlink and it opens up a new window with a terminal that gives us SSH access to the server. So let's start executing our plan. We'll start by examining the contents of the bad.log file using the tail command with the -f flag to follow new updates to the file. We can see that information is being written frequently to the file. To find out the process writing to the bad.log file, we will use the lsof command, which stands for list open files. When this command is executed without any flags, it shows all open files belonging to all active processes. Let's try it out. As you can see, this is more information than we need, and it could be confusing. So instead, we're gonna use the list open files command with the +d flag to indicate that we want open files in a specific directory, which is the var.log directory. This is much better. Here we can see that the bad.log file is being accessed by a process that has the PID of 584. Every process in Linux has a unique PID, which stands for Process ID. The Process ID number is not always the same. You might find that when you go through this scenario on your own, that your Process ID number is different than the one that's on my screen. Now that we have the PID of the process that's writing to the bad.log file, we should terminate it. We will use the kill command to terminate the process. So we will execute kill 584. Let's check the bad.log file again. No data is being written to the file anymore. At this point, we are confident that the task was completed. So let's click the Check My Solution button. We can see that our work was correct and that we've completed the scenario successfully. I hope that this was helpful and that you've learned something new. These videos take a lot of time and effort, so please like and share them with someone that would find them useful. Thanks and goodbye.